Just think about it. The plant was buried and forgotten about for months without water or other care. When dug up, it yielded more food than a whole garden bed. The roots tasted like honeyed fruit, even though they grew in poor soil. Scientists later discovered that it feeds gut bacteria instead of causing sugar spikes. In one study, it improved metabolism without adding calories, but almost no one outside the Andes has ever heard of it. Farmers grew it for centuries until it disappeared from markets. Modern agriculture has quietly replaced such crops with fragile alternatives. This plant grows on its own, reproduces on its own, and requires almost no water. And once planted, it can feed a family for years with almost no effort. 4 years ago, a friend brought strange rhizomes that looked like ugly ginger. He said to plant them but didn't explain what they were, so I threw them into the far corner of the garden where nothing was growing. The soil there was ordinary, without fertilizers or special care. I planted it and completely forgot about these rhizomes for 6 whole months. I literally forgot their existence. Never watered except with rainwater, didn't add compost, fertilizer, or anything else. The months passed unnoticed. Autumn came, and only then did I remember the forgotten plants. I went to see what happened and found huge plants almost 2 meters high. The leaves were wide and green, like those of an ornamental shrub. When I carefully dug them up with a garden fork, there were large roots the size of sweet potatoes underground. I washed them, tasted them, and was amazed. They turned out to be sweet, juicy, and crispy, like an apple with honey. At that moment, I realized that this plant should grow in many more gardens around the world. When I started counting the roots, the numbers shocked me. From 3 forgotten plants, I collected almost 15 kilograms of sweet roots. This is more than my main potato bed, which I tended all summer, produced. Each plant produced 5 to 7 kilograms of edible roots, plus dozens of small rhizomes for propagation. However, I did not spend a single hour of work on them after landing. No hilling, weeding, fertilizing, or pest control. For comparison, the average potato yield in the world is about 2 kilograms per plant with intensive care. Peruvian research from the National Agrarian University of La Molina has documented yacon yields exceeding 10 kilograms per plant under optimal conditions. Moreover, the plants appeared healthy and strong, with no signs of disease or insect damage. The stems were thick, the leaves were dark green, and the root system was powerful. It's as if nature has created an ideal crop for lazy gardeners. The harvest was so abundant that I did not know what to do with all these sweet roots. The first bite changed my idea of what a root vegetable should be. Instead of the starchy potato pulp, I felt an explosion of sweet juices in my mouth. The crunch was like a fresh pear, and the taste was like a mixture of apple, melon, and honey all at the same time. The water content of yacon roots exceeds 85%, making them unusually juicy compared to other tubers. This explains the sensory surprise that everyone who tries them for the first time experiences. Regular root vegetables contain much less moisture. My kids started eating these roots like candy, peeling them and gnawing on them raw, straight from the garden. No persuasion was required. The sweetness was natural, refreshing, and not at all cloying like industrial sweets. However, the most amazing discovery awaited me later. This sweetness did not lead to a sharp rise in blood sugar levels. The secret lay in special compounds that science is only beginning to fully understand. Every time I treated friends to these roots, their reaction was the same. Disbelief, then surprise, then a request for more. This plant is called yacon, and its scientific name, Smalanthus soncifolius, sounds as exotic as its properties. It belongs to the Asteraceae family, making it a distant relative of the sunflower and artichoke. Few people know about this relationship by looking at its tuberous roots. The FAO listed yacon as a neglected crop species, along with amaranth and quinoa, before their global resurgence. This paints a broad picture of lost agricultural knowledge. Many powerful crops have disappeared from modern agriculture for no good reason. Outside the Andean regions, yacon remains virtually unknown, even among experienced gardeners. In Russia, Europe, and North America, only a few enthusiasts grow it. Most people have never heard this name or seen the plant. The paradox is that yacon offers exactly what modern gardening is looking for: high yields with minimal labor. At the same time, it has unique nutritional properties that common root vegetables do not have. This unknown becomes even stranger when you learn about its ancient history in South America. Yacon grows in the Andean highlands from 1,000 to 3,000 meters above sea level, where there is a mild climate with cool nights and sunny days. It was these conditions that formed its unique properties over thousands of years of evolution. The plant has learned to accumulate special sugars that do not freeze at low temperatures. Archaeological finds indicate the use of yacon by the Inca civilization around 1200 AD. Botanical records from Peru and Bolivia confirm its cultivation long before the arrival of Europeans. The Quechua Indians called it yacon, which means watery root. Before Columbus times, yacon was one of the main crops of highland agriculture, along with potatoes and quinoa. The Incas valued it for its ability to grow in poor soils without irrigation. The roots provided a source of sweetness in a diet where sugar cane did not grow due to the altitude. Sixth, the Astrov family has endowed yacon with adaptive traits that explain its incredible drought tolerance and rapid biomass production. It shares these evolutionary advantages with sunflower and Jerusalem artichoke. They all evolved the ability to store carbohydrates in underground organs as a survival strategy. The relationship with Jerusalem artichoke is especially important for understanding yacon. Both plants produce fructooligosaccharides instead of regular starch. This biochemical feature makes their roots sweet, but not high in calories in the traditional sense. Unlike its northern relatives, yacon evolved in high-altitude tropical conditions. This gave it a unique combination of properties: the cold resistance of Jerusalem artichoke plus the heat-loving nature of tropical crops. The result is a plant that adapts to a wide range of climates. Understanding this botanical lineage helps explain why yacon is so easy to grow. Yacon produces two very different types of underground organs, and confusion between them leads to frustration for most newbies. The storage roots hang down like thick, sweet icicles, and the rhizomes are located at the base of the stem in compact, knotty clusters. This system is similar to cassava and dahlia, which also share propagation and storage functions. Storage roots contain up to 70% fructooligosaccharides in dry matter and serve as a storehouse of energy for the plant. The rhizomes remain tough, fibrous, and tasteless because their job is to produce new shoots next spring. Nature has clearly divided these roles. Agricultural extension programs show that misidentification of edible parts is a leading cause of crop abandonment among beginners. A person tastes the rhizome, winces from the bitterness, and decides that the plant is inedible. Meanwhile, the real treasure hangs nearby on thin roots. It is easy to distinguish them. If the root is thick, juicy, and easily broken, it is food. If it is knotty, dense, and attached to the stem, it is planting material. The first time I made this mistake, I almost threw the whole plant away. This dual system makes the yacon virtually invulnerable. Even if the edible roots are damaged, the rhizomes will preserve the plant for the next season. The first piece of yacon defies all expectations from a root vegetable. Instead of the usual mealy texture of potatoes, your teeth are greeted with crispy flesh that bursts with sweet juice. The taste resembles a mixture of Fuji apple, conference pear, and a slight hint of melon at the same time. This sweetness is radically different from table sugar. Fructooligosaccharides create a soft, fruity taste without being cloying. FOS molecules are too large for sweetness receptors to fully recognize them, so sweetness is experienced delicately and naturally. The texture changes depending on the storage time after harvest. Freshly dug roots are crunchy like carrots, but after a few days they become softer and juicier. Enzymatic processes partially break down FOS into simple sugars, enhancing sweetness. Temperature affects the perceived taste of yacon more than other root vegetables. Chilled yacon tastes as refreshing as cucumber, while warm yacon tastes sweeter and more aromatic. Many compare it to exotic fruits that they have never tried. Children eat yacon like apples, peeling with a knife and gnawing whole, which is impossible to imagine with any other root vegetable. Yacon fructooligosaccharides pass through the small intestine undigested as hidden passengers, heading straight to the colon. There they become food for bifidobacteria and lactobacilli, beneficial microorganisms in our intestines. This process is completely different from the digestion of ordinary starch or sugar. The Journal of Agricultural and Food Chemistry published studies confirming the prebiotic effect of yacon and stimulating the growth of beneficial microflora. Scientists found a tenfold increase in the number of bifidobacteria after regular consumption. This effect is comparable to expensive probiotic supplements. The fermentation process of FOS in the intestine produces short-chain fatty acids that nourish the cells of the intestinal wall and improve its barrier function. At the same time, the growth of pathogenic bacteria is suppressed. The gut becomes a healthier ecosystem. However, this uniqueness has a side effect. People who are not used to large amounts of FOS may experience bloating and gas. Bacteria actively ferment unusual foods, producing gases as a byproduct. That is why the first acquaintance with yacon should be careful, no more than 50 grams at a time. A 2009 study in the Journal of Clinical Nutrition demonstrated how yacon syrup improved insulin resistance and reduced body weight in obese women. Participants took yacon extract daily for 4 months. The results exceeded the researchers' expectations. The group of women given yacon lost an average of 15 kilograms of weight without changing diet or exercise. The placebo control group showed no significant changes. Fasting glucose levels decreased by 20%, which is comparable to the effects of some diabetes medications. The University of San Marcos in Lima conducted a series of experiments on volunteers with prediabetes. After consuming yacon for 3 months, participants' glycated hemoglobin levels improved by 30%. Doctors recorded stabilization of daily fluctuations in blood sugar. Japanese researchers from Hokkaido University have discovered anti-inflammatory compounds in yacon leaves. The extract showed activity against markers of chronic inflammation comparable to green tea. Traditional Andean medicine used the leaves to treat diabetes long before scientific confirmation. These studies transformed yacon from an exotic vegetable into an object of serious medical interest. 200 grams of yacon contains about 60 calories, while the same amount of sweet potatoes provides 172 calories. This difference is due to the fact that the body cannot absorb most of the carbohydrates in yacon. Fructooligosaccharides pass through in transit without being converted into energy. The glycemic index of yacon is close to 0 due to indigestible sugars, while that of sweet potatoes ranges from 44 to 94 depending on the cooking method. This makes yacon ideal for people controlling their blood sugar levels. The paradox is that yacon tastes sweeter than many high-calorie root vegetables. The brain receives a signal about sweetness, but the pancreas does not respond by releasing insulin. This combination is unique among natural products. A medium-sized potato weighing 200 grams provides 154 calories and sharply raises blood sugar. Yacon of the same weight is no worse satiating, but the metabolic response remains minimal. The difference becomes critical for diabetics and people with metabolic syndrome. This caloric efficiency makes yacon an almost ideal product for the modern person struggling with excess weight. FAO compared the yield of yacon with potatoes under minimal intervention conditions and found striking results. With low-input farming, yacon produced 12 to 18 tons per hectare, while potatoes without intensive care produced only 8 tons. The difference became even more impressive when calculating labor costs. One yacon plant can produce up to 10 kilograms of edible roots per season with virtually no care. My personal record was 12 kilograms from a single bush, which I watered only 3 times over the summer. No traditional garden crop achieves such productivity. Studies of Andean farming systems have shown that yacon requires 5 times less labor per kilogram of harvest compared to corn or legumes. The plant practically grows itself after planting. Weeding, hilling, and spraying against pests become unnecessary. The scalability is amazing. A 10 by 10 meter plot can produce over 50 kilograms of sweet roots annually. For a family of 4, this covers the need for healthy carbohydrates for several months. In this case, the initial investment is limited to the purchase of several rhizomes. Such a ratio of effort to result seems almost impossible in modern agriculture. The yacon rhizome looks like a gnarled piece of ginger with visible buds from which new shoots will emerge in the spring. Andean agricultural manuals indicate that one rhizomatous group produces 10 to 20 new plants annually. This means exponential multiplication without additional costs. Planting occurs after the last frost, when the soil warms up to 10 degrees Celsius. A hole 20 centimeters deep is dug. The rhizome is laid horizontally with the buds up and covered with loose soil. The process takes minutes per plant. A critical mistake for beginners is to overbury the rhizomes. The buds must be close to the surface, otherwise the sprouts will not have enough energy to break through the thick layer of soil. The optimal depth is 15 centimeters from the bud to the surface. The first green shoots appear after 2 to 3 weeks in favorable weather. By midsummer, a single sprout turns into a powerful bush 1.5 meters high. The root system begins to form storage organs already in July, but the main accumulation occurs in the fall. Balance is more important than abundance of nutrients. I got the best yields on soils of average fertility with the addition of mature compost only at planting. No additional feeding was required during the season. This ability explains its success in Andean conditions. Waterlogged soils become the only serious limitation for yacon. Rhizomes rot in stagnant water conditions faster than most other crops. In areas with poor drainage, it is necessary to create high ridges or add sand to improve water permeability. Chemical fertilizers often do more harm than good, disrupting the natural balance of the soil ecosystem. A mature yacon plant easily exceeds the average human height, reaching 2 meters in height under favorable conditions. Wide green leaves create a dense dome with a diameter of up to 1.5 meters. Such a visual dominant can radically change the appearance of a garden plot in one season. Plant spacing is critical for maximum root yield. When planted closer than 1 meter, plants compete for space, and the yield of each is reduced by 30 to 40%. The optimal spacing is 1.5 meters in each direction. The powerful above-ground part requires adequate space for the root system. Yacon roots spread horizontally over a distance equal to the height of the plant. Thickened plantings lead to intertwining of root zones and a decrease in the productivity of each bush. As a hedge, yacon works superbly, creating a dense green wall as tall as a person. With this planting, plants are placed every 80 centimeters. The root harvest will be smaller, but the decorative effect will be maximum. When planning a plot for yacon, many people underestimate its final size and end up with a jungle instead of a neat vegetable garden. The Andean highland conditions with variable rainfall gave yacon exceptional drought resistance. The plant can withstand periods without watering for up to 3 weeks, which is impossible for most garden crops. The deep root system finds moisture in the lower layers of soil that are inaccessible to surface crops. In my garden, the yacon only receives water once a week in the summer and is completely dependent on rain in the spring and fall. At the same time, productivity remains consistently high. For comparison, tomatoes in the same area require watering every 2 days, otherwise they begin to wilt. Yacon's broad leaves serve as natural sun umbrellas, creating shade for its own root zone. This mechanism reduces the evaporation of moisture from the soil and maintains the microclimate around the plant. Evolution has taught the yacon to save every drop of water. However, during periods of extreme heat above 35 degrees, the plant begins to shed its lower leaves to conserve moisture. This is a signal for the need for additional watering. One abundant watering restores leaf turgor within 24 hours. Yacon's water consumption is 3 times lower than that of zucchini or cucumbers with comparable biomass. In 4 years of growing yacon, I have not used a single pesticide, fungicide, or insecticide. The plant exhibits natural immunity to most pests that attack the nightshade family. Integrated pest management studies show minimal susceptibility in yacon compared to tomatoes and potatoes. Aphids sometimes appear on young shoots at the beginning of the season, but disappear on their own within 2 weeks. Natural predators, ladybugs and lacewings, manage small populations without human intervention. The chemical composition of yacon leaves is probably less attractive to phytophagous insects. Fungal diseases also avoid yacon due to good ventilation between the large leaves. Powdery mildew, gray mold, and late blight, which affect neighboring crops, do not find suitable conditions on yacon plants. Thick, waxy leaves provide an additional barrier to pathogens. Slugs and snails ignore yacon even with a massive invasion of the site. Perhaps the high content of fructooligosaccharides in the tissues makes the plant unsuitable for their digestion. This is a rare quality among lush green crops. The only threat comes from moles, which can damage rhizomes when digging tunnels. Sensitivity to photoperiod triggers tuber formation in yacon when daylight hours decrease in the fall. Until this moment, the plant grows green mass and develops a root system. Switching to storage occurs automatically, without human intervention, like an internal biological clock. The first signs of readiness for harvesting appear in October, when the lower leaves begin to turn yellow and wither. The plant redirects nutrients from the above-ground parts to the underground storage organs. This process lasts 4 to 6 weeks depending on the climate. The optimal time for collection occurs after the first light frost, which completely stops photosynthesis. In the middle zone, this happens at the end of October or beginning of November. Harvesting too early produces less sweet and shallow roots as accumulation continues until the last moment. A completely yellowed and dried above-ground part signals the end of the growing season. At this point, the roots reach their maximum size and optimal chemical composition. Further delay in harvesting may lead to the onset of rotting in the soil. The right time of harvest can increase the yield by 20 to 30% compared to premature harvesting. A garden fork works better than a shovel for removing yacon because the sharp blade easily cuts the fragile roots in half. Mechanical damage statistics show that cut roots lose their shelf life twice as fast as whole ones. Every scratch becomes a gateway for putrefactive bacteria. First, I cut off the stems at ground level, leaving stumps 10 centimeters high for easy removal of rhizomes. Then I carefully dig up the plant in a circle, stepping back half a meter from the center. Yacon roots spread widely and can be located far from the base of the stem. When the earthen ball with roots is removed, the delicate separation operation begins. The rhizomes remain attached to the base of the stem in a dense mass, and the edible roots hang down on thin roots. With a sharp knife, I cut the connecting roots, trying not to damage the tubers themselves. The first harvest is always shocking with the number of roots. From one plant hangs 10 to 20 large roots, each the size of a sweet potato. The total weight reaches 8 to 10 kilograms per bush under favorable conditions. You have to work carefully since fresh roots are softer than boiled carrots and break from careless movement. Enzymatic processes convert some of the fructooligosaccharides into simple sugars within a few days of harvest. Freshly dug roots contain up to 70% FOS, but after a week of storage, the ratio shifts in favor of fructose and glucose. The taste becomes noticeably sweeter and richer. Optimal drying conditions are a temperature of 18 to 20 degrees and good ventilation without direct sun. I spread the roots in a single layer on wooden grates in the barn. After 2 to 3 days, the texture becomes more tender, and the sweetness increases by 30 to 40% according to organoleptic assessment. The process is reminiscent of the ripening of pears or persimmons after picking. The plant's enzymes continue to work, breaking down complex carbohydrates into simpler, more palatable compounds. This natural process cannot be accelerated by heating without loss of quality. The transition from crunchy carrots to juicy pears occurs gradually. On the third day, the roots acquire the optimal consistency, soft but not loose. Further drying can lead to spoilage, especially at high humidity. This process explains why yacon fresh from the ground seems less impressive than after a few days of storage. The first year I washed the entire crop immediately after harvesting and carefully placed the clean roots in wooden boxes. After 2 weeks, half the crop was covered with soft, rotten spots. Moisture on the surface of the roots created ideal conditions for the development of mold fungi, which quickly penetrated deep into the tissues. The optimal humidity thresholds for storing yacon range from 4 to 10 degrees Celsius with moderate humidity. Too dry air dries out the roots to the state of wooden logs. Too humid air provokes rotting. The golden mean is at 60 to 70% humidity. Roots with remaining soil are stored 3 times longer than clean ones. The soil crust protects the skin from drying out and creates a barrier to pathogenic microorganisms. Now I wash the roots only immediately before use, leaving the bulk of the harvest in its natural packaging. Temperature fluctuations destroy the cellular structure of yacon faster than constant heat. Storage in a basement with a stable temperature gives better results than in an insulated balcony with changes. Each freeze-thaw cycle turns some of the roots into mush. Proper storage allows you to preserve the harvest until March of next year without significant losses. Yacon rhizomes require a completely different storage strategy than edible roots. A substrate of wet sawdust or peat maintains the viability of the buds until next spring. Survival levels in sawdust and peat show the highest survival in controlled trials, up to 95% versus 60% in sand. The storage temperature of rhizomes is critical. Below 0 degrees, they die from frost. Above 12, they begin to germinate prematurely. The optimal range is from 2 to 8 degrees. In a city apartment, the bottom shelf of the refrigerator in a perforated bag is suitable. One mother plant produces 10 to 20 daughter rhizomes per season. The mathematics of propagation is impressive. Starting with 3 rhizomes, in a year you get 30, in 2 years, 300. Exponential growth is limited only by the area of the plot and the needs of the family. Checking the viability of rhizomes in the spring is simple. Healthy buds are hard, white or cream-colored, without signs of mold. Shriveled, soft, or blackened rhizomes are discarded. One rotten specimen can infect the entire batch if stored together. Surplus rhizomes become valuable material for sharing with other gardeners in the spring. A 10 by 10 meter plot can produce over 50 kilograms of sweet roots annually if properly laid out. When placing plants 1.5 meters apart, 25 bushes can be placed in such an area. An average yield of 2 kilograms per plant gives a total of 50 kilograms with minimal labor costs. For a family of 4, this amount is enough to consume yacon regularly for 6 months. When calculating 100 grams per person twice a week, the annual requirement is about 40 kilograms. A small plot completely covers the family's needs for this unique product. Scaling is impressively cost-effective. The initial investment in rhizomes pays off in the first season when compared to purchasing exotic fruits of similar nutritional value. Subsequent years provide net profit from free reproduction. Commercial calculations show an income potential of up to $1,000 per 100 square meters if there is a market. However, transportation and storage restrictions make yacon a crop primarily for local consumption. Farmers markets and restaurants are becoming the main distribution channels. Yacon's productivity per unit area exceeds that of most traditional root crops under comparable growing conditions. Raw yacon is cut into strips and immersed in water with a drop of lemon to prevent browning, just like apples. In villages in Peru and Bolivia, this process takes a whole day over an open fire. Modern gardeners use multi-cookers to produce concentrated sweetener at home. Pan frying transforms the crispy yacon into caramelized pieces with a nutty flavor. The high content of natural sugars contributes to the formation of a golden crust at a temperature of 180 degrees. Adding rosemary or thyme creates interesting flavor combinations. Yacon smoothies are refreshing and naturally sweet without added honey or sugar. Blending with apples and carrots results in a balanced drink with a pleasant texture. Children drink such smoothies more readily than store-bought juices with artificial additives. Cooking destroys the prebiotic properties, but retains the pleasant flavor and soft texture. Tolerance thresholds for fructo-oligosaccharides are typically 10 to 15 grams before gastrointestinal effects occur in non-accustomed individuals. 200 grams of fresh yacon contains approximately 12 grams of FOS, which is close to the comfort level for beginners. Exceeding this dose causes bloating, gas, and abdominal discomfort. The process of adaptation of the intestinal microflora takes from 1 to 3 weeks of regular consumption of small portions. Beneficial bacteria gradually increase in number and efficiency in processing FOS. Once adapted, most people tolerate up to 30 grams of fructooligosaccharides without unpleasant symptoms. People with irritable bowel syndrome or other functional digestive disorders should take particular care. Their tolerance threshold may be significantly below average. It is recommended to start with servings of 20 to 30 grams of yacon every other day. Heat treatment partially destroys FOS, converting them into regular sugars, which reduces the prebiotic effect but increases tolerance. Boiled or fried yacon causes fewer digestive problems in sensitive people. The first experience with yacon should be in moderation, despite the temptation to eat more due to the pleasant taste. Global supply chains favor crops with long shelf life and mechanical strength, putting yacon at a disadvantage. Economic data shows that losses during transportation of fragile root crops increase production costs by 40 to 60%. Large retailers avoid products with a high percentage of spoilage. The violation of the temperature regime at any stage from farm to fork leads to rapid spoilage. Most distributors are not willing to invest in dedicated infrastructure for a niche product. Standardization and certification of yacon as a food product is lacking in most countries. Regulatory barriers make it difficult to reach the mass market even with production capacity. Bureaucratic procedures can take years. These systemic limitations make yacon a crop primarily for personal cultivation. The rate of spoilage of yacon, when the cold chain is broken, reaches 30% per day at room temperature. For comparison, potatoes lose their marketable appearance within a week under the same conditions. Every hour at temperatures above 15 degrees reduces the shelf life by several days. The mechanical strength of yacon is 5 times lower than that of potatoes or beets. Shaking during transportation leaves dark spots from internal damage, which quickly turn into areas of rotting. Special packaging with shock absorption increases the cost of delivery by 2 to 3 times. Standard vegetable storage facilities with automatic temperature and humidity control work better for yacon than primitive cellars. However, investments in such equipment pay off only for large production volumes. Small farmers cannot afford professional storage systems. International trade in yacon is practically non-existent due to the impossibility of long-term transportation by sea. Air freight makes the product uncompetitive on price. Only freshly frozen yacon can travel long distances without critical loss of quality. These physical restrictions turn yacon into an exclusively local culture with a distribution radius of no more than 100 kilometers. Cost per calorie calculations show virtually zero costs for yacon after the rhizomes are initially planted. With a harvest of 50 kilograms from a plot of 10 by 10 meters, the cost per kilogram does not exceed 20 rubles, taking into account the depreciation of tools. Store-bought analogs are 10 to 15 times more expensive in terms of nutritional value. Home growing solves all transportation and storage problems in one go. The roots are dug up as needed and consumed in an optimal state of freshness. No transit losses, cold chains, or special packaging are required. Quality control in your own garden guarantees the absence of pesticides, chemical preservatives, and other additives. Yacon is grown without a single spray, which is especially important for families with children or people with allergies. Organic origin is confirmed by personal participation in the process. The educational value of growing yacon for children is invaluable. They observe the full cycle from planting rhizomes to harvesting and understand the connection between labor and food. The ability to dig a sweet root straight from the ground is more impressive than any store-bought treat. Independence from market prices and availability makes yacon a strategically important crop for family food security. Yacon deserves much more recognition than he receives in the modern world. It makes no sense that a plant so easy to grow, so productive and so useful remains virtually unknown to millions of gardeners. This is an injustice to a wonderful culture and a missed opportunity for the people. The movement to bring back lost cultures is gaining momentum around the world, and yacon fits perfectly into this trend. Just as quinoa and amaranth have returned from oblivion to store shelves, yacon can find a second life in gardens and on tables. Every bush grown is a small act of restoring biodiversity. If you have a spare corner in the garden and a desire to try something new, give yacon a chance. Plant 4 or 5 rhizomes, leave them to grow on their own, and wait for the fall harvest. It is very likely that the result will pleasantly surprise you with quantity, quality, and taste. Always leave more rhizomes for storage than seems necessary. The extra ones can be given to friends and neighbors, helping this wonderful plant spread slowly but surely. Yacon deserves to be known and grown by many more people. Join us in future episodes, where we will discover even more useful, unusual, and undeservedly forgotten plants for your garden.